All right, so let's just have this g of x, and it's going to be x cubed minus x, and we're going to test to see if it's even or odd. So if, according to these two definitions up here, if I look at g of negative x and I get g of x back, which is x cubed minus x, then that's going to tell me that it's even. The other thing that could happen is I put negative x in, and if I get the opposite of g of x, what would the opposite of g of x be? It would be all terms have opposite signs. So it would be negative x cubed plus x. Then I know that it is odd. So I'm going to put negative x in here and evaluate at g of negative x. And I'm going to use parentheses everywhere I do this so that I don't mess up my negative signs, because it'll happen if you're not really careful. Okay, so I drop negative x in for x and evaluate. Negative x cubed is just going to be negative x cubed. Minus negative x is going to be plus x. That is the opposite of what I started with. When I started off, x cubed was positive, x was negative. Now, it's the opposite, right? X cubed is negative, but x is positive. That is the opposite of g of x, and that means this function is odd. That wasn't so bad, was it? Was that so bad, Courtney? Let's take let's take some function h of x. Let's imagine that it is x squared plus 1. If I plug a negative x in there and I get h of x back, it's even. If I plug negative x in there and I get the opposite of h of x, it's odd. Well, let's see what happens. H of negative x would be negative x squared plus 1. Anything squared is going to come out positive. So negative x squared is x squared. This is plus 1. That is exactly what I started with. That function is even. Now there was this whole symmetric part that was added to the definition there that we haven't said anything about. So I'm going to use the calculator to say stuff about it. Let's look at this g of x. G of x was x cubed minus x. And don't pay any attention to the derivative thing down there. It's turned off. So let's look at x cubed minus x. And I should zoom in so you can see better what's going on in the origin. There's x cubed minus x. Use your imagination for a second and imagine that you could grab this part up here and wrap your fingers around that up there and pull it down towards you so that it was curved down this way. Can you imagine that? And then if you were to flip it, bend it right on this point right here, and take it over, it would lay down exactly on that line. Do you have good imagination, Amelia? Can you imagine that? Okay. Could you imagine that, Cody? Yeah. That's symmetric about the origin. Let's take a look at the other one. The other one was x squared plus 1. There's x squared plus 1 in standard zoom. You guys know about symmetry. Maybe not around about the origin, but you definitely have seen it about y. If I take this part and I bend it right here where it meets the y-axis, it would lay down exactly on that part over there. So that is symmetric about the y-axis. The other one was symmetric about the origin. So all the stuff we can do now that we know about even and odd, I could give you a function and I could ask, is it even or odd? And you would test it by dropping in a negative x. I could give you a graph and I could say, is this graph even or odd? And you could look to see if it's symmetric to either the origin or the y-axis, and you could tell me. I could give you part of a graph, like maybe just the right half of this graph, and I could tell you that here's a picture of part of f of x, and that f of x was even, and you could reasonably come up with a reasonable sketch to complete it. And I could do the same thing with an odd function.
Now, evens are symmetrical across both.
Why?
And then
Odd is origin. Odd and origin both start with O. Hey, I just came up with that one. Got a million of them. And that's a bunch of stuff that we can do with even and odds. Before we jump into the next thing, we should review the common functions. These common functions, there's 6 little functions that you've seen all through Algebra 1 and Algebra 2, and you've seen them so much that if I say one of them, if you don't almost immediately get some sort of picture in your head about what its graph looks like, then you have not been paying attention in Algebra 1 and Algebra 2. These are 6 graphs that when you see them, you should get a instant picture in your mind's eye. So there is constant functions, there is the identity, there is the absolute value function, there is the square root function, there's the square, and the cube. 1, 2, 3, 4, 5, 6. Great. Okay. So you might not instantly get an image of them from those words, but once I give you one, you will. So here's a constant function. Example of a constant function, y equals 4. Do you have a picture of that? Here's a picture. 4. It's a line that goes through y equals 4. Imagine that. But you had that picture, right? The identity. That's y equals x. That is the equation where all the x and y coordinates are the same. Remember, this is the line that goes through the point 1, 1, 2, 2, 3, 3, 4, 4. Has a slope of 1, goes through the origin. Looks like it's trying to make that British flag. Y equals negative x would complete the job. There's the absolute value equation, like y is the absolute value of x. Do you know what it looks like? Frady, what's it look like? Absolute value. The what? Like what? Erica, what's it look like? Take a guess. That's y equals x. We're talking about absolute value of x. Sarah, what's it look like? Shaded? No. No shading. What? And Mason, what's it look like? Absolute value means it's always positive, and look at all this negativity down here. That's not going to happen. Gary, what's it look like? Amelia, what's it look like? Yeah, it's a V. It's the V thing. Let's see if we can find out how to graph that one. I think it's in the math menu, maybe under number. There it is. Abs. Absolute value of x. Graph. It's a V.